In triangle ABC, D lies on a B, E lies on a C, and DE is parallel to BC. We know a D is 6, DB is 4, and the area of triangle a DE is 54. We need the surrounding quadrilateral's area.
The answer choices are 246, 150, 96, and 42. Let us separate the small triangle, the full triangle, and the band-shaped quadrilateral before calculating.
The diagram nests triangle a DE inside triangle a BC, since DE is parallel to BC. The triangles have the same shape.
Exactly. The parallel segments create matching corresponding angles, and both triangles share angle A. Angle similarity tells us triangle a DE is similar to triangle a BC.
The side a B is not written as one number, but D splits it into a D and DB, so the full corresponding side is 6 plus 4.
Now compare the large side AB with the corresponding small side a D. The large to small length scale factor is 10/6, which simplifies to 5/3.
I am tempted to multiply the small area, 54, by 5/3. That gives 90, and then subtracting 54 gives 36.
That uses a length factor as though area had only one dimension. Area depends on both a base and a height, and similarity multiplies each of those lengths by 5/3.
So the base contributes one factor of 5/3, and the height contributes another. Their product is the square of the length scale factor.
That relationship follows directly from the triangle area formula. If both base and height are multiplied by k, 1/2 times base times height is multiplied by k squared.
Triangle a DE is the smaller copy, so the outer triangle's area is 54 times 25/9.
Write the calculation before simplifying. The area of triangle a BC equals 54 times the square of 5/3.
Since 54 divided by 9 is 6, the arithmetic becomes 6 times 25. That is 150 square units for the full triangle.
150 is choice B, but it is not what the question asks for. Choice B represents the whole triangle a BC, including the small triangle a DE.
The quadrilateral DBCE is everything inside triangle a BC, except triangle a DE. Its area is the large area minus the small area.
We know both areas now. Subtract 54 from 150. Before we reveal it, pause and compute that difference.
150 minus 54 is 96. Therefore, the area of quadrilateral DBCE is 96 square units.
That value appears as choice C. We should still verify the scale relationship and the subtraction before locking in the answer.
The small to large side ratio is 6/10 or 3/5. Squaring it gives 9/25, so the small triangle should be 9/25 of the full triangle.
Test the areas. 9/25 of 150 equals 54, exactly the given small triangle area.
The regions also recombine correctly. The inner triangle has area 54 and the surrounding quadrilateral has area 96. Together, they make the full area, 150.
Now compare every choice. 246 adds the two relevant areas incorrectly. 150 stops at the whole triangle. 42 subtracts in the wrong numerical relationship.
96 is choice C, and it is the only choice that both subtracts the small triangle and respects the squared similarity factor.
The reusable rule is simple. When similar figures have length scale factor k, Their areas have scale factor k squared. Then subtract only if the problem asks for the region between them.
My checklist is to prove similarity. Build the complete corresponding side, square the length factor, scale the known area, and subtract the inner region from the whole.
The full triangle has area 150, the inner triangle has area 54, and the difference is 96. The area of quadrilateral DBCE is 96, choice C.